All right, good evening, everybody. Let's start our first lesson on matrices. So we're going to divide the lesson matrices into the two components. So we're going to look now at matrices one. And here's how we start. We said that a matrix is a rectangular arrangement of numbers enclosed in a pair of curved or square brackets. A matrix is a rectangular array of numbers enclosed in a pair of curved or square brackets. A matrix is usually denoted by a capital letter. The plural of matrix is matrices. All right, the order of a matrix. The order of a matrix is the number of rows by the number of columns. The order of a matrix is the number of rows by the number of columns. Example 1. State the order of the following matrix. So, matrix A has two rows. So the rows are horizontals and the columns are vertical. So matrix A has two rows and it also has two columns. So matrix A is a 2 by 2 matrix. Now, a matrix has the same number of rows and column, or a matrix in which the number of rows is the same as the number of columns is called a square matrix. So a 2 by 2 matrix is a square matrix. B, this matrix has two rows. Remember, the rows are horizontal and it has three columns. The columns are vertical. This matrix is a 2 by 3 matrix. All right. I guess it could be called out a rectangular matrix. All right. And it's simply the number of rows is not the same as the number of columns. C is a 3 by 2 matrix. All right. The first number in the order, the first number is for the number of rows, and the second number is for the number of columns. D is a 2 by 1 matrix. It's a 2 by 1 matrix, and this is called a column matrix. And this is simply because the entire matrix is just one column. E is a 1 by 3 matrix, and this is called a row matrix. All right, and F is a 1 by 1 matrix. All right. So the order of a matrix is the number of rows by the number of columns. All right, you need to be able to state what is the order of a matrix. Addition and subtraction of matrices. Essentially, matrices of the same order may be added or subtracted by adding or subtracting corresponding elements. Matrices of the same order can be added or subtracted by adding or subtracting corresponding element. So the word corresponding here means in the same position. So first of all, if we're going to add two matrices, the two matrices must be of the same order. And 1 and 2, we add or subtract matrices by adding or subtracting corresponding elements. All right, so let's have a look at A or I. I says A plus B. So A is the matrix 3, 7 minus 8, 4. So those are the elements of the matrix. And it's plus matrix B, which is minus 3, 0, 5, 4. So how do we add two matrices? We add two matrices of the same order by adding corresponding element. So over here to the left, 3 is the top left element, and over to the right, negative 3 is also the top left element. So a positive times a negative is a negative 3. Minus 8 to the left plus 5. Alright, so minus 8, um, minus 8 plus 5. So it's minus 8 plus 5. Then we have 7 plus 0. 4 is the bottom right element plus 4, the bottom right element in the matrix to the right. So we add matrices by adding or subtracting corresponding elements. All right. 3 minus 3 is 0. 7 plus 0 is 7. Minus 8 plus 5 is minus 3. And 4 plus 4 is 8. So 0, 0, 7, minus 3, 4 is the matrix A plus B. All right, let us do B plus A. B plus A. So the same two matrices, but we'll basically change the order. So we have minus 3, 5, 0, 4. That's matrix B plus A, which is what? 3, 7, minus 8, 4. So in matrices, order is important. So if the examiner said you have to add B plus A, you must ensure you put B first and then A second. When you deal with matrices, the order in which you put things is important. Remember, we add our subtract matrices by adding or subtracting corresponding elements. The word corresponding means that means in the same position. So it's minus 3 top left plus 3 top left in the right matrix, then 5 top right plus minus 8, a positive times a negative. A positive times a negative is a negative 8. This is 0 plus 7 and 4 plus 4. So 4 is the bottom right element in B and 4 is the bottom right element in A. We add matrices by adding corresponding elements. So this is the matrix minus 3 plus 3 is 0. 0 plus 7 is 7. 5 minus 8 is minus 3. And 4 plus 4 is 8. All right, so here's something interesting. We can see clearly that the matrix A plus B is the same as the matrix B plus A. The matrix AB is the same as A plus B is the same as the matrix B plus A. So from this we can say that addition of matrices is commutative. Addition of matrices is commutative. So maybe we can write that statement somewhere. All right. And the word commutative here here means that the order does not affect the outcome. So we changed the order from A plus B to B plus A, but the answer came out to be the same. So we can conclude that the addition of matrices is commutative. Let's have a look at A plus B plus C. So triple I, we have A plus B in bracket plus C. No, the A plus B in bracket is just telling us that A plus B must be done first. This is telling us that A plus B must be done first. But we already did A plus B, and A plus B is 0, 7, minus 3, 4. So we can take out A plus B and put what? 0, 7, minus 3, 4. That's A plus B. Now plus C. C is 302 minus 2. 302 minus 2. So remember, we add matrices by adding corresponding elements. So this is 0 plus 3. Top left elements, minus 3 plus 2. Top right elements, 7 plus 0. Bottom left elements, 4. A positive times a negative is a negative 2. So what we have is 0 plus 3 is 3, 7 plus 0 is 7, minus 3 plus 2 is minus 1, and 4 minus 2 is 2. So the matrix AB in bracket plus C is 3, 7, minus 1, 2. All right. The fourth is A plus B plus C in bracket. We have A plus B plus C in bracket. All right. All right, so this is telling us that we need to do B plus C first. So let's do B plus C. B plus C. So B would be minus 3054 minus 3054 plus C, which is 302 minus 2. So this is going to come out to be minus 3 plus 3. Remember corresponding elements. 5 plus 2. That's the top right elements. 0 plus 0, bottom left. And 4 plus minus 2, which is minus 2. So this comes out to be minus 3 plus 3, 0, 0, 7, 2. All right. So here we change up the grouping and the answer didn't come out to be the same. So here we can see that the addition of matrices is not associative. The addition of matrices is not associative. Associative is talking about changing of the grouping. So the order means the same, but we change up the grouping. The grouping tells us what is to be done first. So we changed up what is to be done first, and the answer did not come out to be the same. Wow, what a biggie. There's an error here. This one is not finished actually. So let's erase this. Alright, we might come back to show that that is not the case. This one is not finished. We did b plus c, but what we did not do was a plus b. Sorry. So we need now to add this. So we have b plus c, so we need to find now what is a plus b plus c. So we didn't finish. Entire thing was a little bit premature. So a is what? Let's go back and have a look at a. A is 3, 7 minus 8, 4. 3, 7 minus 8, 4. Plus b plus c, which is 0, 0, 7, 2. So we're going to add, we add matrices by adding corresponding elements. That's 3 plus 0 minus 8 plus 7, 7 plus 0, 4 plus 2. All right, so this worked out to be 3, 7 minus 1 minus 1. This is saying 6. All right, so let's see if we made an error somewhere. Don't appear so. So we did not make an error. Nope. All right. We can probably check back this fact sometime, but it seems to be the truth. The two did not come out to be the same, so the addition, the addition of matrices is not associative. All right, so we could really check back this fact to see maybe if we made an error somewhere, but don't have time to do it now. So what for now, we'll say that the addition of matrices is not associative. All right, let's look at a minus b. So we're looking at a, and this becomes it's IV, so this is v. A minus b. All right, so that would be a, which would be 3 minus 8, 7, 4. That is a minus b. B is minus 3, 5, 0, 4. So a minus b, remember we subtract corresponding element. 3 minus minus 3, which is plus 3, minus 8, minus 5, 7, minus 0, 4, minus 4. So a minus b is actually equal to a minus b is equal to 6, 7 minus 13, 0. Right, I think I might need to add other page. So let's add a page. All right, so now the next thing we're going to look at is b minus a. So basically the same thing, but we're just going to switch them around. So lastly, and this is vi, b minus a. B minus a would be minus 3054 minus 3054. That's b minus A, which should be 3, 7 minus 8, 4. So that'll be 3, 7 minus 8, 4. So remember, we add or subtract matrices by adding or subtracting corresponding elements. So this would be minus 3, minus 3, 5, minus 8, which is plus 8. A negative times a negative is a positive. 0 minus 7, and 4 minus 4. So minus 3 is minus 6. If the signs are the same, you add and keep the sign. 0 minus 7 is minus 7. 5 plus 8 is 13. And 4 minus 4 is 0. So we can see clearly that A minus B, A minus B is not equal to B minus A. Therefore, the subtraction of matrices is not commutative. And all that simply means is that it's affected by order. If you change the order in subtraction, it is going to affect the outcome. So the subtraction of matrices is not commutative. All right. This says scalar multiplication of matrices. And all that simply means is that you're multiplying a matrix by a number. All right, so you simply multiply a matrix by a number. In this example, we're given A. So A, we're given A, and we're asked to find 3A. So we're asked to find the matrix 3A. Remember, matrices are usually denoted by capital letter. This would be 3 times the matrix A, which is what? Minus 3, 4, 2, 1. So how do we multiply a matrix by a number? Simply, we multiply every element in the matrix by that number. So it's going to be 3 times minus 3, which is minus 9. 3 times 2, which is 6. 3 fours, which is 12. And 3 times 1, which is 3. So if A is the matrix minus 3, 4, 2, 1, 3A is the matrix minus 9, 12, 6, 3. So when you multiply a matrix by a number, you simply multiply all elements in the matrix by that number. B. B says 1/3 B. So this is 1/3 of B. B is what? Minus 6, 9, 9, 12. Now, so we're multiplying everything inside by 1/3. Multiplying by 1/3 is the same as dividing by 3. So this is literally minus 6 divided by 3, 9 divided by 3, 9 divided by 3, 12 divided by 3. All right. So this would be equal to minus 2, 3, 3, 4. So we're looking at multiplying a matrix. C. We're looking at multiplying a matrix by we're looking at multiplying a matrix by a number, and we said when you're multiplying a matrix by a number, you simply multiply all elements in the matrix by that number. Multiplying by 1/3 is the same as saying divide by 3. Now we're asked to find 2p minus q. So that would be 2p, which is what? 6 minus 4, 6, 3 minus q, which is 3, 0, 1, 7. All right, so Bumda says, well, you must multiply before you subtract. So let's multiply before we subtract. So 2 6 12. 2 times minus 4 is minus 8. 2 6 12. And 2 times 3 is 6. Minus 3, 0, 1, 7. So now we're subtracting matrices. So we must subtract corresponding element. So this will be 12 minus 3. That's the top left element. 12 minus 1, top right. Minus 8 minus 0, bottom left. 6 minus 7, bottom right. This would be equal to 9 minus 8, 11 minus 1. All right. All right. Now we'll come to multiplication of matrices. Now, multiplication of matrices is arguably the hardest part of matrices. So if you can learn multiplication of matrices, you're basically three quarter there. So first thing, this is what we said. Two matrices are compatible for multiplication if the number of columns in the first matrix is equal to the number of rows in the second matrix. So what is that saying? Essentially, this is saying that you can't just multiply any two matrices together. In order for you to multiply two matrices, the two matrices have to be compatible. So it's not like numbers, you can multiply any two number you feel like. But matrices is different. For you to multiply two matrices, the two matrices must be compatible for multiplication. And for the two matrices to be compatible of multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So in this diagram here, all this diagram is saying that if A is a m by n matrix, means that A has m rows and n columns, and B is a n by p matrix. So B has n rows and what? P columns. So we can see that the number of columns in A, which is n, the number of columns in A, which is n, here is equal to the number of rows in what? B, which is also n. So because the number of columns in the first is equal to the number of rows in the second, the two matrices are compatible for multiplication. Now m is the number of rows in the first, and p is the number of columns in the second. So m, so this is columns. P is the number of columns in the what? Second. So MP is the order of the matrix product. So if I multiply a matrix that has 3 rows and 2 columns by another matrix that has, let's say, 2 rows and 1 column, I'm going to get a 3 by 1 matrix. So the number of rows in the first by the number of columns in the second is the order of the resulting matrix when you multiply two matrices. All right, here's an example. This example says, so we're given 3 matrices and we're asking which of the following matrix product is possible. Remember, it is not possible to multiply two matrices unless, or it is only possible to multiply two matrices when the two matrices are compatible for multiplication. And for the two matrices to be compatible for multiplication, the number of columns in the first must be equal to the number of rows in the second. Now, if the matrix product is possible, word possible should have been here. So if it is that yes, we can multiply these matrices, we need to state the order of the resulting matrix. So let's look at the first one. A is a 2 by 2 matrix. 2 matrix, and B is a 2 by 3 matrix. So here, let's just change the color here a little. The number of columns in the first matrix, which is 2, is equal to the number of rows in the second matrix. So therefore, the two matrices are indeed compatible for multiplication. So AB is possible, and 2 by 3 is the order of the resulting matrix. All right. So how do we show that they are compatible? The number of columns in the first must be equal to the number of rows in the second, and the number of rows in the first by the number of columns in the second is the order of the resulting matrix. All right. So the second one says AC. AC is so let's take a look at C. A, we already state, is a 2 by 2 matrix, and C is a 3 by 1 matrix. So change the color again. Therefore, AC is not possible, or it is not possible to find the matrix product AC. Why? Because the number of columns in the first, which is 2, is not equal to the number of rows in the second. So in such a case, the two matrices are not compatible for multiplication, and you can't multiply them. Two matrices are compatible for multiplication when the number of columns in the first is equal to the number of rows in the second. So let's move along. You guys can stop the video and do the other two if you want. It's up to you. But I think I've proven my point. All right. So let us now actually practice multiplying two matrices. And remember, I told you that this is the greatest hurdle or the biggest problem in the topic. If we can overcome this, we can learn the topic easily. All right, so we're given some matrices and we're asked to find. So these are all 2 by 2 matrices. Since they're all 2 by 2 matrices, they are compatible for multiplication. All right, so we're asked to find the matrix product AB. We're asked to find the matrix product AB. Now AB, A is the matrix 1 minus 3, 2, 5, and B is the matrix. All right, let's move the position of this. Let's move it up here. And B is the matrix 3, 1, minus 2, 4. All right, to the right of the screen, we sort of see just a little note on multiplying of matrices. And here's how we start. We start by saying when multiplying When multiplying matrices, we multiply the rows of the what? First matrix. So, for emphasis, let's change the colors. So these would be the rows of the first matrix by the columns in the second matrix. So these would be the columns of the second matrix. So let's say that again. When multiplying matrices, we multiply the rows of the first matrix by the columns of the second matrix. Now, how do we go about doing that? Essentially, we multiply the first element in the row by the first element in the column plus the second element in the row multiplied by the second element in the column. All right. So how do we multiply a row by a matrix? We multiply the first element in the row by the first element in the column and the second element in the row by the second element in the column. All right. And every time we multiply a row by a column, whenever we multiply a row by a column, we get an element. So if we multiply, we get an element in the answer. So if we multiply the top row by the left column, we're going to get the top left element in the answer. All right, so let's remove some of those stuff that we just put in. Some of these lines, so that we can actually do this question. All right, so this is first row. This is the first row, first element, second element. In the column, first element, second element. All right. So we're multiplying two matrices. Let's multiply the first element in the row by the first element in the column. So it's 1 times 3, which is 3. And then first element in the row by the first element in the column. And then the second element in the row, which is 2, by the second element in the column, which is 1. 2 ones are positive 2. All right. All right. So we're going to use the same top row, but this time now we're going to multiply the top row by the right column. So this is 1, first element in the column, second element in the column. So we're multiplying two matrices. How do we multiply two matrices? When we're multiplying two matrices, we multiply the rows of the first matrix by the columns of the second matrix. We already multiply the top row by the left column. Now we're going to multiply the top row by the right column. How do we multiply a row by a column? The first element in the row times the first element in the column. So that's 1 times minus 2, which is minus 2. Then what? Plus the second element in the row, which is 2, times the second element in the column, which is 4. 2 plus 4 is 8. All right. So I just multiply the top row by the left column and the right column. Every time we multiply a row by a column, we get an element. If we multiply the top row by the left column, you get the top left element. If you multiply the top row by the right column, you get the top right element. So let's go to the bottom row. First element in the row, second element in the row, first element in the column, second element in the column. So it's the bottom row by the left column. We're going to get the bottom left element. So minus 3 times 3 is minus 9. And 5 times 1 is 5. Same bottom row, but this time by the right column. So it's first element in the row, and negative times a negative is a positive by the first element in the column. Minus 3 times minus 2 is 6, and 5 times 4 is 20. Let's simplify. 3 plus 2 is 5, minus 9 plus 5 is minus 4. Um, minus 2 plus 8 is 6. And 6 plus 2 is 8. All right, let's write this 5 properly. All right, so the matrix A plus B is A multiplied by B is 5 minus 4 is 6, 8. All right, let's find BA. BA. So we're changing the order. Let us see how will that affect the outcome. So it's 3, 1 minus 2, 4. 3, 1 minus 2, 4. Multiplied by A, which is 1 minus 3, 2, 5. All right, so we're back at it again. We're going to multiply two matrices. How do we multiply two matrices? We multiply two matrices by multiplying a row by multiply the rows of the first matrix by the columns in the second matrix. How do we multiply a row by a column? We multiply a row by a column by multiplying the first element in the row by the first element in the column and the second element in the row by the second element in the column. So let's multiply. 3 ones are 3. A negative times a negative is a positive. 3 twos are positive 6. All right, let's use the same top row. We're moving on over now to the right column. So we're multiplying the first element in the row. All right, so the ones and the twos I'm putting above the numbers. That's how to help me sometimes to just keep track of what I'm multiplying. So any number that has a 1 over it, I multiply those two numbers together. Any number that has a 2 over it, I multiply those two numbers together. So it's 3 twos, I get 6. And minus 2 times 5 is minus 10. So now I'm going to move to the bottom row. I just multiply the top row by the 2. Let's multiply the top row by the 2 columns. So now I'm moving to the bottom row also by the 2 columns. 1, 2. All right, 1 times 1 is 1. 4 times minus 3 is minus 12. All right, so multiply the bottom row by the left column. That's going to give me the bottom left element. Now I'm going to multiply the bottom row by the right column to get the last element, the bottom right element. 1 times 2 is 2. 4 times 5 is 20. So this becomes 9 minus 11 minus 4 and 22. All right. So AB is not equal to BA. This is interesting. So AB is not equal to what? BA. So matrix multiplication is not commutative. All right. So let's have a look at AI. I'm gonna bother to do AB times C. We did AB before, so it's simple to multiply AB, which is this, by C, which is that. So I'm not going to do that, but I want to do A times I. So I is what you call an identity matrix, and essentially it's a matrix in which the diagonal elements are ones. So like here, the diagonal elements, here they're ones. So I is an identity matrix. So let's multiply A by I. A is 1 minus 3, 2, 5. So let's look at A I. So this is IV. AI. So A is I have it here. 1 minus 3, 2, 5, multiplied by I. I is 1, 0, 0, 1. So I is the identity matrix, and it's a matrix in which the diagonal elements, or the leading diagonal elements, are all ones. All right, so let's multiply our matrices. Um, first, second, second. 1 times 1 is 1. 2 times 0 is 0. So 1, 1. First element in the column, second element in the column. 1 times 0 is 0. 2 times 1 is 2. So I just multiply the top row by the left and the right column. So now I'm going to go down to the bottom row by the left column. How do we multiply a row by a column? First of all, how do we multiply two matrices? We multiply two matrices by multiplying the rows of the first matrix by the columns in the second matrix. How do we multiply a row by a column? First element in the row by the first element in the column, and the second element in the row by the second element in the column. So minus 3 times 1 is minus 3, and 5 times 0 is 0. So the same bottom row, but this time now by the right column, to give us the bottom right element. Minus 3 times 0 is 0, and 5 times 1 is 5. All right. So what we end up with, our final answer is what? 1 minus 3, 2, 5. All right. So if you're observant enough, you'll notice that 1 minus 3, 2, 5 is the matrix A. So multiplied A by I, and we got back what? And we got back A. All right. So it appears as if multiplying by I is equivalent of multiplying is sort of like multiplying a number by 1. When you multiply a number by 1, it remains the same. When you multiply a matrix by the identity matrix or by I, you get back the matrix. So A times I is A. All right. All right, and this is also true. I times A is also equal to A. All right, so you can do that on your own. So that would have been V. You can do that on your own, and I'm sure you would get the same results. So AI is equal to IA, which is equal to A. So when you multiply a matrix by the identity matrix, you get back the matrix. All right, this is an identity or a fact that is going to come in handy in in it's going to come in handy shortly. All right. So the last thing I think we're going to look at um, in matrix 1 is equal matrices. The last thing we'll look at is equal matrices. Yeah. And after we look at each equal matrices, then we're going to look at that would be the end of matrix 1, and then we'll start matrix 2 afterwards. Now, if two matrices are equal, they are of the same order and corresponding elements are equal. So if two matrices are equal, the two matrices must be of the same order. And if they're of the same order and they are equal, corresponding elements must be equal. So two matrices which are of the same order, two matrices are equal if they're of the same order and corresponding elements are equal. All right. Um, let's look at the second example, and then we'll come back to the first example. So here we're told that given that the first matrix here, that this matrix product is equal to the matrix 11, 11, 1 minus 6, we're asked to determine the value of A. So if they told us that the product of these two matrices is equal to that, I figure let us multiply the two matrices. So this would be my solution. It would be 2 minus 1, A, 4. All right, let's ensure that our A doesn't look like a 9. A, 4 multiplied by 1, 2, 3 minus 1. And that would be equal to 11, 11, 1 minus 6. So let's multiply 1, 2, 1, 2. 2 times 1 is 2. A times 3 is 3A. The numbers I'm putting above the 1 and 2 I'm putting above the elements. You don't have to do that, especially when you become more competent with the thing. I think it's A times 3. This should be 3A. As soon as you become more competent in the multiplication, you don't need to do this. But this is definitely a skill that you must practice to ensure that you get it. 2 times 2 is 4, and A times minus 1 is minus A. All right. So let's go down to the bottom. 1, 2, 1, 2. Minus 1 times 1 is minus 1. And 4 times 3 is 12. Move over to the right column. Minus 1 times 2 is minus 2. And 4 times minus 1 is minus 4. So, and this is equal to 11, 11, 1 minus 6. So this is 2 plus 3A down bottom of 11. Then at the top we have 4 minus A. Down the bottom we have minus 2 minus 4, which is minus 6. And this is equal to 11, 11, 1 minus 6. All right. So these two matrices now. So now we're down on the left hand side, we have one matrix, and on the right is equal to another matrix on the right. So these two matrices are equal. And what we said is that if two matrices are equal, the two matrices must be of the same order, and corresponding elements must be equal. So corresponding elements would be at the top here we have 2 plus 3A. that's the top left element in the left matrix, would be equal to 11, which is the top left matrix, top left element in the right matrix. So let's solve this simple equation for A. Positive 2 goes over and become negative. So we have 3A is equal to 11 minus 2. 3A is equal to 9. Then divide both sides by 3. A would be equal to 3. All right. So let's test. So we're asked to find A, and we did. We found that A, we found that A is equal to 3. But let's test it. Let's test it. Could we test it? Yeah, we sort of could test it. All right, because we have another equation with A. 4 minus A is the top right element, on the left, and that is equal to 1, which is the top right element on the right. Let's solve the simple equation where 4 minus 1, positive 1 come over to the left and becomes negative 1. Negative A goes over to the right and become positive A. 4 minus 1 is 3, so we have A is equal to 3. So in this example, we're told that the product of two matrices is equal to another matrix, and in one of the two matrices there was a letter that was unknown, A, and by going through this process, we found the value of A, that A is equal to 3. What must we remember? That if two matrices are equal, if two matrices are equal, the two matrices must be of the same order and corresponding elements must be equal. All right, I'm not going to bother to do example 1. You can have a look at it. Look at this video, go over it where necessary. I already sent you the homework on matrices. It's not finished. There's a part 2 to matrices. So I'll send the part 2 as soon as I can.